Good morning, everyone, and welcome back to school. And I guess most of you, maybe this is afternoon, maybe this morning, what it is. This is lesson 821. We're going to be talking about angles with polygons. You can complete by taking notes on paper or on the Pear Deck. You can follow along with the Pear Deck and write on the screen with me, or you can write on paper. Make sure you upload. If you would do paper, make sure you uploaded it. If you do Pear Deck, I'll find it. So you don't need to even say anything else to Pear Deck unless I'm told otherwise. Okay. So let's go ahead and get started. We're going to be talking about angles of polygons in chapter 8. So let's just make sure we understand what we're dealing with. So let me move my face. So in chapter 1, we proved that the sum of the interior angles of a triangle is always 180 degrees. What about the sum of the interior angles of other polygons? What about their exterior angles? Is it different if they are regular? So today we're going to find angles inside and outside of a polygon. So before we do any of that, let's make sure we know what a polygon is. So a polygon, poly means many, and gon means sides. So many sides, polygon. Polygons must be closed and must consist of line segments. So this, with a curved segment, is not a polygon because it's curved. Okay. This is also not a polygon because it's not closed. Okay, so that's why those are not polygons. But polygons basically line segments. So when you think about polygons, we got squares, we have rectangles, we have octagons, stop signs, we have pentagons, we have hexagons, we have all these different names for all, and triangles officially are part. So the straight sides, more than 3 or more, and that's what we're dealing with. Okay, make something a polygon. So we're going to start with interior angles and what we know with triangles and see what we can come up with. So let's go ahead and do that. All right, the interior angle is the angle on the inside of a polygon. So I'm going to see where my face is best. I think probably up here. We'll see. I might move it later or get rid of it altogether. An angle on the inside of a polygon is called the interior angle. So that's an interior angle. When we talk about the sums of the angles in a triangle, we are always talking about, hey, you add up all 3 interior angles, you get 180. So that's an interior angle, no big deal. Okay. So maybe that's not the right place for my face. Okay. Like that, because that's the lowest I could go. Determine the sum of the measures of the interior angles of the pentagon below. So let's see if we can figure out. So, I mean, I'm not going to grab a, that seems annoying to try to measure it. Maybe there's something else I can do. So, there's a triangle. And if I add up all the angles in this triangle, I'm going to get 180. And here's 2 more triangles. So I have this adds up to 180, this adds up to 180, and this adds up to 180. So the angles inside will add up to 180. So that's what I'm saying when I say they add up to 180. I'm referring to this. And so when I move to this one, we have this angle, and that angle there. Those add up to 180. I'm going to make that blue. And then down here, we'd have this one, that one, and this over here. And those add up to 180. So all the angles will be, and notice how this angle right here, those 3 pieces make that whole angle, and those 2 pieces make that whole angle. And so we've got all the angles, all 5 of them, 1, 2, 3, 4, 5 angles. So it's going to be 180 plus 180 plus 180, which is 540. No big deal. And I did that by breaking up into triangles. Pretty straightforward. All right, let's check it out. So the sum of the interior angles then and what's going on. So we're going to go ahead and fill in this. Put that up there. This is 180. We know that. We just did this one was 540 and it was just random, so that will work all the time. The idea is to think how many triangles there are. So there's 2 triangles in this one. So that's going to be 180 times 2 or 180 plus 180, whichever way you like to think about it. So 360. For 6, there'll be 1, 2, 3, 4 total triangles. So that will be 540 plus 180 again, which is 720. Make sure that's right. Yep. And then 7, we're going to have 1, 2, 3, 4, total of 5 triangles. Oh, my brain is not working. 720 plus 180, 900. Okay, that's what I thought, but just wasn't processing. And then 8, 1, 2, 3, 4, 5. And so there'll be another 180, so that's 1080, 100. Now, I don't want to draw a 100-gon. I have no desire to draw an octagon, a polygon that large. No desire at all. But I can, if I'm kind of feeling what's happening here, maybe I can make a guess. So let's just kind of look at this. So the interior angles, we started with 1 triangle, then we had 2, 3, 4, 5, 6. So number of triangles. Might be easier to do. So that was 1 triangle, 2, 3, 4, 5, and 6. So how many triangles will there be in 100-gon? And it is 98, 2 less than the number of sides. 1, 2, 3, and if we count it up. Okay, but we're starting at 1 on the 3rd thing, so we're going to be 2 away. We're always 2 off. Okay, and so this will be n minus 2 for the number of triangles. And so then this will be 180 times 98, and give me a second, calculator. Just have to find one. $180 times 98 is 1777. Nope. Yep. Nope. That's wrong. Oh, that's why. I typed it wrong. Like that. Number makes no sense. Equals 17640. And so this, since it's n minus 2, my final one will be 180 times n, take away 2. So the number of sides, take away 2, times 180 is how we find the number of the sum of the interior angles. No big deal. Let's move on. So what is the sum of the interior angles? And so we kind of did these 2 questions. Let's answer them again. So we were just really supposed to fill out through 8. I just went ahead and did a little, sorry about that. So we know there's 98 triangles in 100-gon. So 180 times 98 equals 17640, if I recall, yes. And so that's what we did. Okay, we're going to put it in our table, so I'm not going to write it down again. So an n-gon has n minus 2 triangles. So in other words, can I find it no matter what the number of sides is? If you can do 100, you should be able to just replace the number 100 with n. Okay, and so this is going to be 180 in an n-gon. 180 times n, take away 2, is the sum of angles, interior angles. There we go. Let's move on. Okay. You're working to find the value of x in the diagram below. Your friend says that's easy because all the angles are equal. You can just divide. So Jeremy is your friend, and his name was under my face, so I didn't know. This is easy because all the angles are equal, and we can just divide. So what are we dividing, and what's he talking about? And so all the angles are equal. The sum six, yes. And so in a sixtagon, we found out that when there were 6 sides, it was 720. So we know that it's 720 equals 6x, because all the angles add up to 6x. X plus x plus x plus x plus x plus x plus x equals 6x. So that's the sum, and this is the sum from our table earlier. And so x equals 6 goes into 72, 1 into 220. X is 120 degrees. Yeah, that's right. Questions? Let's continue. An angle, so we know that an interior angle is an angle on the inside of the polygon. The exterior angle is an angle on the outside formed by extending the sides. So this is the exterior angle. Exterior angles are much easier than interior angles in a lot of ways. We'll talk about that in a minute. But that's what we mean by an exterior angle. So it's not really part of the polygon. In fact, you have to visualize a line extending that doesn't really extend off of it. But that's what we have. Okay? Let's go ahead and move on. Okay. So what can we determine about the exterior angles of other regular polygons? So let's figure out what's going on. So we've got an equilateral triangle. And we know that all the angles are 60. Okay, because it's an equilateral triangle, we're supposed to know that. And so the exterior angle, this angle right there, and the angle of 60 degrees must add up to 180 because they make a straight line. So I'm actually going to type that. That's really way too big. Interior, the sum. Oh, I don't mean to move that. I didn't mean to advance the page is what I didn't mean to do. Okay. So it's a 180 degrees because no matter what we're talking about, because it makes a straight line. Okay, all right. That is not what I meant to do. I keep doing that. All right, so all angles equals inside are 360. The exterior angle here must then be 120, so that 60 plus 120 is 180. let's do an octagon. So the inside of an octagon, that interior angle, is actually going to be quite big. It looks like that. Imagine 8 sides. So this angle, we know that it's the total number, the 1080, which is the sum of all the interior angles, divided by 8, which is going to be 1/28. Okay, I'm just going to let the calculator handle it. $135. Okay, so the exterior angle, this one, will be 180 minus 35 is 55. Okay, a decagon, that's 10 sides. So this was 8 sides. This one is 10 sides. We haven't done a pentagon, but it will be 180 times 8. So that's 1440. That's the interior angles divided by 10 gives me 144 for the interior angle, a single interior angle. And so my exterior angle is 36. Okay, and then 12 sides. $40 plus is 1800 divided by 12 is 150. So my exterior angle is 30. Okay, so we did part, that's I. Now, E is to calculate the sum of the exterior angles. So what we're going to do is, and by the way, regular means they're all the same. Okay, what we're going to do is we're going to take the number we found and times it by the number of sides. Um, 36 times 10, 360, and then 30 times 12 is also 360. So they're all 360. The hardest one here is 55 times 8, but I knew that they were all going to be 360. The exterior angles in a triangle, in any polygon in the world, regular or irregular, always make 360 because they're getting, and think about what happens with a polygon as we add more and more sides. It looks more and more like a circle. Okay, let's move on. All right, so there we go. Compare results from part D, write a conjecture. I just told you the answer. The sum, the exterior angles of a regular polygon is always 360. That's my conjecture. So a little computer freak out right there. So the sum of the exterior angles is always 360, and it's always true. Okay, it's always true. All right, let's move on to the next part. What's the measure of one exterior angle of a regular n-gon? So, of a regular, so that means we're going to take 360 and divide it by the number of sides, and that will give me the answer. But only if they're all the same. Only regular, because they will all be equal. The exterior that's it. Okay. I believe we're coming close to it. And so there's this table. So what you want to do with this table is take everything we've done and put it in this table. So I'm going to go ahead and pause the video and write everything down. And then I'll turn the video back on and it'll all be there. And so that way you can record it in your notes. This is really important. So make sure you get this all down. This should be turned into me. Okay, but again, I'll give you a picture in just a second. And there you have it. So this was a mistype, so sorry about that. It should be triangle, quadrilateral, pentagon, hexagon, heptagon, octagon, hundredgon, and n-gon, and then the number of sides should have moved. So this, sorry about that. You can write them over here and just switch the titles if that's easier, whatever works. Number of triangles, 1, 2, 3, 4, 5, 6, 98, etc. Sum, those should all say degrees on them. On these two, second to last two columns, it should be one interior angle of a regular polygon, and then the sum of the exterior angles. Okay, and that's it. All right, make sure you get all of that copied down as part of your work, and I will see you guys soon. Have a great day.